I am Dr. Johnson SAVARIMUTHU, Assistant Professor of Mathematics, St.Joseph College, Cuddalore. I am going to take Operation Search EMT618S. Definition of OR. OR is scientific method of providing executing department with the quantity, the phases for decision regards the operation under the model. Scope of OR. It technique have been used in the range situation such that as in the industry, defense, planning, agriculture and public utilities. Limitation of OR. Mathematical model application only scientific categories of problem. 1. Bring a new fixed. Generally, there is a resistance from a employer to the purpose. Phase of OR. 1. Judgment, research and action. Application of OR. Linear programming has been applicative solved problems. Dynamic programming has been applied to capital budgeting. Inventory control has been helpful. Inventory control have been used to determine economic ordering quantity. Queuing theory has been used helpful to solve problem, repair and maintenance of broke down machine. Decision theory has been helpful is water, solution, medicine, etc. LPP. Linear programming is a technique finds the optimal value of the linear function of the second variable subject to the some condition. Objective function. The linear function to be optimized, maximized or minimized is called objective function. Constraint. The condition expressing the relation between the variables are called constraint. Decision variable. The variable that appear in the objective function is called decision variable. Feasible solution. The value of the position variable which satisfies the constraints are called feasible solution. Optimal solution. The solution which optimizes the objective function is called optimal solution. Simplex method. We have to define slack variable. If the inequality is of the form less than or equal to, by adding positive variable to the left hand side of the inequality, we convert into inequality in order that the maximum value of the linear function is slack variable or introduced into the objective function with zero coefficient. Surplus variable. If an inequality constraint of the form greater than or equal to, a positive variable is subtracted from the left hand side of the constraint to convert into equality. Such a variable is called surplus variable. Artificial variable. Introduction of a surplus will not result into a feasible solution. To overcome this, we introduce a artificial variable into the constraint. The coefficient of the artificial variable in the left hand side objective to the objective function. Simplex algorithm. Converting inequality constraint into the equality constraint by introducing the set of slack variables S1, X2, etc. Introduce zero coefficient to the slack variable in the objective function. Prepare the simplex table. Take the initial solution as x1 equal to 0, x2 equal to 0 and so on, so that z equal to 0. Simplex table consists of a components. The first component is the first column is the table giving current variable, contribution, quantity. Current variable are those variable in the constraints which take positive values. Contribution, their contribution are 0 or their coefficient of the in the objective function. Quantities, their quantities are the values on the right hand side of the constraint. Simplex method. Solve maximize z equal to 4x1 plus x2 subject to the constraint 4x1 plus 3x2 less than or equal to 12. 3x1, 4x2 greater than less than or equal to 12. x1, x2 greater than or equal to 0. First we have to write standard form of LPP. Maximize z equal to 4x1 plus 7x2. The inequality constraint the is of the form less than or equal to. We can add slack variable. Maximize z equal to 4x1 plus 7x2 0s1 plus 0 is 2 subject to the constraint 4x1 plus 3x2 plus s1 equal to 12. 3x1 plus 4x2 plus s2 equal to 12. x1, x2, s1, s2 greater than or equal to 0. See the table. Construct Zj. Zj value 0, 0, 0. We can calculate Zj minus Cj. Zj minus Cj values, all the values are negative value. We have to choose most negative in the column. Here x2 variable entering, x2 variable leaving. Therefore, the new pivot equation is 3 by 4, 1, 0, 1 by 4. We can calculate new equation, old equation minus new pivot element into new pivot equation. Since Zj minus Cj greater than or equal to 0, the optimal solution is reached. Therefore, x1 equal to 0, x2 equal to 3. Therefore, maximize z equal to 4 of 0 plus 7 of 3 equal to 21. Solve. Maximize z equal to 21x1, 15x2 subject to the constraint x1 plus 2x2 less than or equal to 6. 4x1 plus 3x2 less than or equal to 12. x1, x2 greater than or equal to 0. Write standard form. Here we are having two constraints. We are using slack variable s1, s2. Maximize z equal to 21x1, 15x2, 0s1 plus 0s2 subject to the constraint x1 plus 2x2 plus s1 equal to 6. 4x1 plus 3x2 plus s2 equal to 12. x1, x2, s1, s2 greater than or equal to 0. Quantity CV, C. We can calculate. Already I told you Zj minus Cj. The value minus 2 minus 15. We are maximize. The objective function is maximize. We can choose most negative 15. Then most negative 21. We can choose. This column is pivot column. Therefore, x1 entering variable, s2 leaving variable. Therefore, new equation, old equation minus new pivot element, new pivot equation. Therefore, since Zj minus Cj greater than or equal to 0, therefore, so that the optimal solution is reached, x1 value equal to 3, x2 equal to 0, maximize z equal to 21, 3 plus 15, 0. Therefore, the value equal to 63. Thank you.